Ideally, if you want to learn how to design for sheet metal, you want to learn to design as simple as possible so you can make fabricators compete.
The more upfront and center the DFM can be for engineers, the better.
Right. Welcome to the Next-Gen Metal Fab Podcast. I'm your host, Tim Heston. In each episode, my co-host, OSH Cut's Caleb Chamberlain, and I will bring you conversations about what the future could look like for precision sheet metal and tube fabrication.
Don't miss your chance to see the latest in metal fabrication solutions at the Fabricators Technology Summit, August 20th and 21st in the Chicagoland area. This exclusive event, hosted by FMA, offers opportunities to visit local shops, see the latest equipment in action, and network with others in the industry. Visit fmamfg.org for more information. And now, back to the episode.
Hello, this is Tim Heston. I'm with the Fabricator magazine, and thanks so much for joining us for this inaugural episode of Next-Gen Metal Fab, a podcast that's with Caleb Chamberlain of OSH Cut. We had an idea of getting this podcast together several months ago, a journey that started at this point about a year or two ago. Our digital editor, Gareth, came across his online ad, and I clicked on it and said, all right, this looks like to be, okay, maybe just another quoting aggregator site, perhaps something, some kind of network of shops. But no, it was a place where you could upload files and directly get a quote almost immediately, and even get some design for manufacturability data from cutting end as well as forming. So Caleb, welcome.
Yeah, happy to be here.
Yeah, we are going to just kind of, talk about the next, we call this the Next-Gen Metal Fab Podcast because we're talking about the future of what we think, where this industry is headed. We're kind of at an inflection point. I see all sorts of interesting pieces of the digitization puzzle out there, where all sorts of potential of where shops could be going in the future. And everybody's at a different stage and tackling it in a different way. But to get us grounded, Caleb, why don't you tell us your story? How did you get into the precision sheet metal fabrication business?
Yeah, I'll jump into the story, but just riffing a little bit on what you just said, Tim, this is a really exciting time to be in metal manufacturing at all. It's kind of hard to see it when you're in the weeds and solving the day-to-day problems in manufacturing. But if you just look at the trajectory of what's changed already, in our lifetimes, it's actually insane. I was talking to my dad the other day about how he's seen technology change in his career, and it's been a huge dramatic shift over a single lifetime, dating back to full room computers and punch cards, all the way to what we're doing now with just computers with insane computational power, driving massive AI engines that are, if not smarter than humans, soon to be smarter than humans. And then in the mix of that is manufacturing and how we build physical product. And all these technologies are finding their way into fabrication in really unique ways. And it's really, really cool to see where it's going and to see how we can apply that technology to make making things easier.
How did you get into precision sheet metal fab? Tell me your story.
Yeah, our origins, we started 6 years ago. In a month, it'll be 6 years since we got the wheels turning on the company. But it was my brother and I who were working on a variety of different projects that all required fabricated metal. And we found that the purchasing experience was kind of difficult, primarily because we were bringing the kind of work to shops that nobody wanted to do. Really high mix one-off parts that they would never see again. So not a huge win for most shops structured for production. But it was hard enough that we said, hey, let's buy a laser and let's start a company to streamline some of these processes for our particular kind of work. So we founded OSH Cut, we bought a laser, immediately found out that customers also need bending. So we added bending within a year. And we've just iteratively added new services as we went, and we just moved to a new facility. We now have 53,000 square feet, 50 employees, 3 flatbed lasers, 2 lasers, 2 soon to be 3 press brakes, a couple deburring and edge rolling machines, and so on. So yeah, we've seen a lot of traction, some pretty rapid growth, mainly because we're meeting that kind of middle market area where where most shops aren't structured to want to do that kind of work. So it's been a great thing for us.
Yeah, it kind of bring me through the development of your customer experience as far as, the initial, how it started. What was the initial experience like? And then what's it evolved to today?
Yeah, so initially we started like any old shop. Now, it was always our intent to automate a lot of the purchasing with software. And it took us about 6 months after our launch in July 2018 to release our first app, which allowed you to upload just a flat pattern, like a DXF, and then get a flat part. We didn't have bending at first. And then within another 12 months, we released a version 2 app, and then we added 3D model support and so on. But the basic idea is that we want to remove barriers or remove complexity around the quoting process. So ordinarily you might upload a part or send a part to a shop via email. They've got to bring that in. Maybe they're looking at the print, trying to figure out if they can make it. There's going to be some back and forth to figure out whether the tooling works or not, whether it's manufacturable at all. It's a very labor-intensive process, which is fine for production. But we said, well, we want to automate all that. So in our system today, when a customer uploads a part, our system automatically unfolds the 3D model to create a flat pattern, which can be manufactured. It provides a price in whatever quantity they punch in, and it provides nesting online and actually shows them the nest so they can get an idea how it utilizes material, and whether there might be waste there that can reduce their costs if they maybe shave a 1/2 inch off the part size so it fits better on a sheet. And then it also runs DFM, so a manufacturability check on bending. So it actually puts it on our tools and renders the bend sequence as it happens. And if it collides or a punch can't access a bend region or whatever, then our system says that, shows them what the problem is, and they can take their design and iterate and re-upload it. So all of that is usually a manual process from shops. And again, it's fine for production, but it's not so fine if it's a one-off that you're going to do once and never again. So our system streamlines that and makes it possible for people to do it.
Right. So kind of bring me through your pipeline concept. We've talked about your pipeline concept as far as, all right, we need to make it fit this pipeline because any manual intervention of a job, how do you iterate that out of the process so that you could expand your sales funnel, so to speak, to use some buzzwords, but then still keep it in that pipeline to keep that job flowing from order to ship.
Yes, that's a good analogy. So we call it our pipeline, our production pipeline, and in every step of fabrication, there's just a way that we do things. We cut blanks on a laser, we bend on a press brake, and we put parts through a particular kind of deburring machine. And so what we have is this pipeline on the production floor that can do a certain class of parts really, really well. And if we can't do it because it requires equipment we don't have, or it requires special engineering to break apart into multiple pieces that can then be joined together or whatever, we just reject it on the front end. And then parts that do come into our system, we can actually push them into our standardized processes and they just flow like in a river. You inject parts in the pipe, they flow. Everybody on our production floor knows how to do the job. We have a bunch of software, scheduling automation, digital production consoles with work instructions and everything else that just sits on the front end. And so that we know what work to do and when. And so anything that gets put into that system tends to get through the system really efficiently. And then as we say no to certain classes of work because we can't do it, maybe we don't have the right dies or the right equipment, it exposes areas where we can widen that funnel. If there's more that we can do, and then we build the automated processes to make sure we can do it efficiently, we expose it to the front end, and now our addressable market just increased by some amount.
So kind of give me a for instance with that. Say if you have a collision on a brake that keeps happening, and okay, maybe we buy a gooseneck that's this size because we're getting a lot of parts that require that. Is that the kind of thing you're talking about?
Yeah, exactly. In fact, we started with a set of gooseneck punches, and now we use a much like a swan neck punch, which is also twice as deep. So we can handle side flanges better. And the swan neck punch allows for a lot more aggressive return flange.
Right, exactly.
And then we pair that with straights so that if there's a flange that bends up and hits the front side of the punch, then obviously you can't do that on a swan neck. So we've got straights to handle those. And yeah.
Right. Does all this data now, all this data, you've been in business for 5 years now at this point?
6 years. Yeah.
6 years. So you've got all this data now. How does this shape your, say, because I'm looking at this, it's like, do you have like an ideal setup at the break now where it's like, all right, well, this is the ideal that covers 80% of the orders coming in or 30% of the orders, or is it just too various? That's just, or does it
pretty high mix.
Yeah. So it's just, but it does guide your tooling selection and go, okay, these are the tools we need to buy or extend or perhaps get a hem tool or something to that effect.
Yeah, and that is a good point. We don't have a hemming tool yet.
Right.
Part of the complexity there is that when you have a 3D model produced by who knows what software that has a hem on it, maybe the bend on that hem is a cylindrical bend and we can unfold it with our software, and maybe not. So that's the challenge with hems. It's an easy operation to perform, less to intuit from a 3D model that's a hem.
Right. Now let's back up here a bit as far as, again, your origin story is fascinating, but you had an experience with the printed circuit board industry and kind of bring me through how that industry operates, the custom PCB industry, basically, and kind of how that served as a model and a jumping point for OSH Cut.
Yeah, so in my past life, I was an electrical engineer and built a lot of circuit boards. And when you design a circuit board, you produce a set of files called Gerbers, which is the set of files that define the solder masks and the copper layers and the interior layers and silk screen layers. You upload that online in any number of different places, and you can get a price instantly. And you can pay extra to get it really fast if you want, even as fast as the same day turnaround. And that's the norm in the circuit board industry. It works out. Actually, there's tons of consolidation there. I didn't know that, but I met with a fab owner just a few weeks ago. And yeah, there's very few players in that industry now because there's been a lot of consolidation. But there's a lot of quote unquote companies that happen to send all their work to these centralized circuit board fabricators. Very interesting. But the takeaway though is that it is actually really easy to get custom circuit boards done, and it's ridden the tech wave because circuit boards are high tech, software is high tech, and they just kind of are joined at the hip, you could say. And what we wanted to do with fabrication is similar. We want to provide, say, next day or same day shipping, and we do that. We can quote a job and ship it same day. And it is like, that was our model. It's possible to do it. And it also, the analog with circuit boards is also really interesting as well, because with a circuit board, there's only so many things you can do on a circuit board. And there's very specific constraints around how narrow a copper trace can be and still come out okay. And so, in the circuit board industry, you have to design around the shop that's going to produce your part. And really, that ought to be the same thing for fab shops. Customers ought to know what tooling they need to design for.
Right.
To be able to make the part.
Yeah, and I can see such potential in certain product families like NEMA enclosures or something to that effect, where it's like just a standard, all right, this is an enclosure, and this is how you design it. And here's the software stack built around that to actually fabricate it. And but there isn't always an issue. When I first talked with you guys and learned about your operation, my mind went immediately. There's a company, and I've spoken with them a bunch about 24/7 Taylor Steel in Europe, and it's a large operation, over 100 million euros at this point a year. And they're buying tubulars like crazy, apparently. but they have flat, obviously a bunch of flat cutting lasers as well, and automatic tool change brakes. And but talking to the founder, he said, "Well, we're just cut bend." To try to get beyond that is a very difficult aspect to actually do that. But then when you talked about printed circuit boards, I'm like, yeah, but PCB boards are very complex. And then we got IIoT and fabrication coming on, where you're actually tracking the job routing throughout. There's more math, there's more data being involved as far as where jobs are going, what job routing is, where there's so much potential. There's like, do you think this model could go beyond cut bend? Well, you're already beyond cut bend with powder coating, right? You've added powder coating, right? But is it in-house powder coating or outsourced with a partner?
It's with a sister company.
Yeah.
By one of our co-founders, basically. But yeah, that's interesting because we actually have tied our software together, which we could talk about. But our software books jobs in their software automatically, and they just kind of talk. But that is a good question, and it's something we think a lot about, and we're working really hard on right now, actually.
Yeah.
We found that we acquire a lot of customers every month, and we're talking 200 businesses every month and new customers. We serve individuals as well, and we do maybe 40% of our volume to individuals, but where the rubber meets the road, where we make our monies with businesses. And a very, very high percentage of these companies are just trying to simplify their supply chains. And so it's really hard to take an automatic quoting engine like what we have and bid on an assembly that might contain all kinds of, like, how do you create welding fixtures for this thing? And how do you make sure it's built right every time? And what are the critical dimensions that have to be nailed every time? And also, what does the customer need on the back end? Do they need this shipped in a very specific way? We've got a customer that we're building some custom weldments for, and the packaging and palletizing of that product is part of the work instructions. So the work starts to get very specialized and customized, and so it's actually really hard to fit that in a narrow funnel like what we've built. It is actually an open question how far that can go, because in the PCB world, consolidation has happened. In the fabrication world, it's kind of happening, but I mean, there's just so many different industry verticals that require so much different stuff. It goes way far beyond just cutting a blank on a laser and bending it.
Right.
So it is an open question. How much consolidation can there be on our end? How much capability can we bring in-house to serve our customers and still be good at it?
Kind of my experience covering the industry, what's interesting to me is that because the industry has been so fragmented, the front-end processing has been very non-standardized. And so you have a lot of different relationships, a lot of different kinds of, heck, I visited a shop not too long ago with steel roll dies, it's like, it's that the die is still works, and the design of the product has not changed in 40 years. So why change it? And so, but there's nothing digital about the whole process. It's still in paper prints. This is before CAD. And so it's, you have that all the way up to new iterations of design and the way information is communicated. And then at the same time, there's lack of sheet metal knowledge. And so, I see more and more shops trying to fill the void of, they're doing more DFM meetings with their customers to try, because, the retirement wave is happening and you have less knowledge of purchasing and buyers of what can be made and what can't be made. And engineers, a fabricator just called me the other day. It's like, can't we just have a radius? Can we just have a radius on the part, please? But what's interesting is when I see your software in action, it's a great communication tool, because it gives, hey, this is the 3D model, this is our language, and this shows how the metal elongates, it shows how the metal bends, and so this is how we have to accommodate, and you worked it all into a simulation, which is fabulous.
We've had multiple customers that have pointed out that when they can see how it's going to bend and when they see the shape of the punch and die, it just changes how they design stuff. And So I think it's a good thing for engineers to understand. It's a never-ending cycle. I mean, every engineer that gets trained on how to design for sheet metal, for every engineer that gets that training, there's another 10 that enter the market having never had the experience yet. And so, repeat. The more upfront and center the DFM can be for engineers, the better.
Right. And of course, there's a push and pull with DFM because, I've seen some DFM efforts. It's a great sales tool for fabricators because you can design around a panel bender you may have, or design around a punch laser combo that you may have, that you've got certain attributes of this part that couldn't be made other way. You need those machines to do that. And it's a competitive advantage. And so people design around it. And there's so much cost taken out, and that's great. But then again, you back up to the big picture. It's like, all right, how's your supply chain? Ideally, if you want to learn how to design for sheet metal, you want to learn to design as simple as possible so you can make fabricators compete.
So I was reviewing a design for a customer the other day that had very obviously never ordered a sheet metal part before. And I don't mean that in a derogatory way. It was just, they just didn't know. But we've got a long list of things that we check in our system to see if we can make a part. And there's spacing between bends to make sure that the punch, that it can sit on the die after one of the bend has been performed. There's just tolerance issues. They had holes that need to line up after literally 9 subsequent bends, none of which had gauging surfaces to perform the bend. So lack of gauging surfaces, lack of flange support, lines in too close proximity, and a bunch of other stuff. It's like literally every single thing that could be wrong with this part is wrong with it. But you could 3D print that thing. I mean, if you're willing to pay $1,000 for it.
Yeah, I'm just imagining kind of a potential of a 3D printed piece where, because a large constraint, and why I say bending is such a pain, is because you cannot have exact tolerances because you have sheet metal thickness tolerances, because of gauge tolerances, because you don't have the same thickness, or there's a hard spot, or there's all sorts of these, so it's not a machining level tolerance.
Yeah, there's an art to designing around sheet metal, understanding what the constraints are and making it work anyway. Yeah.
Right. And, it's interesting is that, one of the articles that got the most traction online was this one article I wrote about this pie in the sky nano-engineered sheet metal, where they had nanoparticles inside the sheet metal. And this was out of the UCLA research. It's just research, so we'll see what happens. Who knows? Because he was good, but everybody called me. It's like, yeah, because oh, wow, that means you can actually have precise forming capabilities of this, and it'll actually have some precision to it, so I can design to it. But then on the other end of that, it's like, yeah, but why do we need that? Is there something in these products?
Can you produce that sheet metal for $800 a ton?
Exactly. I mean, maybe not. But then again, it's why are these tolerances being called out? And a lot of it's just, because people design for machining, and then they just forget to, this has to be formed, which is why I think your communication is great, and where software is going to play a role, especially software linking businesses together. So kind of bring me through that story of the powder coating arm of it's your brother's organization, or?
Brother-in-law, actually.
Oh, brother-in-law. Excuse me, brother-in-law.
So it was there's actually 4 co-founders, and for simplicity, we talk about Jacob and I, who are operationally involved. But there's also a brother-in-law, McKay Christensen, and my dad, who was involved as well, and he's spearheaded our safety programs. But anyway, it's my brother-in-law, and he's got 10 businesses. He's a very energetic, visionary kind of a guy, but started this powder coating company for an unrelated thing. And then when we found out our customers really want powder coating, it was just like, well, they know software, we know software, and we just kind of connected the two systems. They have APIs, we have APIs. So when a customer submits an order in our system contacts theirs and says, hey, I got this job coming up, so make sure you have the right powder, basically. And then when everything's ready and we've aggregated multiple jobs that use the same color, we book a job, and then they actually come pick it up and bring it off and work on it. So it integrates really well.
So how far do you go on the initial quoting end of it? So in other words, like if you're quoting for powder coating, all right, what's the masking requirement and how can we hang this and make sure that we can hang this so that the coating is clean, that kind of thing. And how dense can it be, all that, on the hanging.
Yep. So we've got a weight limit and a size limit, which is pretty relatively straightforward. But we kind of get that. It's actually, our size limit is whatever we can fit in the van that's transporting it to those guys.
That's good engineering spec.
Right.
Yeah.
Does it fit in the van? Any tapped features called out as requiring masking, and that adds to the price. And then hanging requirements matter too. We wrote software that actually analyzes a part and looks for features that it can hang on. And it could be hooked shaped or it could be a hole. And it's got to be close enough to the edge that it can actually hang. So, and if there's no feature that it can hang on, our system says powder's not available and here's why. And that makes it a little easier as well.
Oh, interesting.
As far as quoting goes, they've got a quoting model and they provide software that we actually run on our own server and that we use to generate the quote. And it periodically reaches out to their servers to update parameters and stuff so that what we bid, we add a little bit of a margin to it, and then that's what we price it at.
And do they do they have a software system on their end that customers can go to them directly, or how does that work as far as the rest of their customer mix?
Yeah,
and it's kind of the same stack that you started with, in other words, and kind of
it's simpler in a lot of ways because instead of saying we're going to take a 3D model of a part to coat, they have a kind of a class of different kinds of things that they've learned how to bid on that people frequently order. And so people can use their website to just go in there and submit that kind of an order. Our system's a little more tightly coupled where we actually send them images of the geometry, and we have features of the part like the total surface area and weight and size and everything. And we provide that information. So on their system, when our jobs pop up, they've got a list of parts with thumbnails that show what they look like, where they currently are, when the job needs to be done, and that kind of stuff. It just kind of appears in their system, and then they do the work.
Interesting. And is it a manual setup? Is it an inline setup or booth setup, or all of the above?
Yeah, they've got booths for spraying, and then they've got they're moving into a new building right now, and they've got some pretty high tech stuff for doing surface prep on the material, so that things can flow through really fast. They try not to sandblast. I know sandblasting is really common, but they have other ways of doing the surface prep for our parts in particular.
Interesting. All right. Well, it's kind of to finish things off. I just kind of wanted to finish the story of the evolution of your shop. So you just completed a move earlier this year. What was the impetus behind that move? And describe your new home and your plans for it.
Yeah, well, I mean, the simple fact is we were just out of space. We first entered, we had, I think, 4,000, maybe 5,000 square feet in the first shop that we rented, no office space. We expanded to take an office in the same unit that we were in. Then we expanded to take an adjacent unit and add, I think, 7,000 square feet or something. And then again, we expanded. So we had 3 different units, 3 different offices. The units were adjacent, but we had ramps between them and holes knocked in the walls. And they're just not an ideal manufacturing environment. And we had, I think, 18,000 square feet, maybe 17,000 of usable warehouse space. Our new space is a big concrete tilt-up building. It's got 53,000 square feet, just one nice office instead of 3 little ones that individually felt like caves. And we're surprised, but we're doing record volume now. We haven't added people. We have added some equipment, but it's just very surprising as our efficiency is shot through the roof just by having a better layout. Not having to drive forklifts up and down ramps. And it's been a real surprise. We did not expect it, but not only are we keeping up with record volume with the same number of people, we're actually pulling ahead. Like as of this moment, the lasers have already cut almost everything that we're going to ship next week.
All right.
aside from the rush orders that come in. So it's pretty crazy how big a difference layout makes.
Yeah. Explain that layout for me. What was it? Is it traditional U layout? Because you have a blank. It's a greenfield, right? So it's all no. Or is it or was it somebody? Was it a brownfield site? Somebody you moved in?
No, brand new building, so we could
Okay.
plan the layout. We planned the electrical and everything. We experimented with a lot of layouts, but in the end, we put all our inventory against one wall, and the lasers are right next to that. So shortening that transit time has helped. And then parts flow off the lasers into a couple of really close cells, one for finishing, one for bending, and then it goes from there to quality. So it's not a U shape, actually. We've experimented with different designs. We've thought about doing like a U shape, like a little lean manufacturing cell. And we might end up there down the road, but for now, it's not quite that layout.
Right. Well, as long as you got the receiving and shipping in separate areas, you're fine. You go right through, right? Versus
it's more of a line than a U shape. Yeah, the way it is right now. Yeah.
That's great. Well, we can, again, dive into the weeds. We can probably talk after all afternoon about layouts. But this will be a topic for future podcasts.
And I would like to add in closing, we talked a little bit about our operation today, but in this podcast, I think we'll use what we're doing at OSH Cut as a touchstone, certainly because we're doing some novel things, but there's so much happening outside of this context. And there's so much happening with new technologies like AI that we're actually feeling in development of our custom software tools. And I really hope that we can deep dive into a lot of these industry trends, new technologies, and look at how things have changed and maybe think about what's going to change in the future. Just like, how can we prepare for this? And how can we ride the wave and not get drowned in it? A lot of really interesting stuff happening, and that I'm really excited to talk about it in future episodes.
But yeah, it's a fun time. The industry is at a kind of an inflection point. We shall see where we're headed. But again, thanks for joining us for Next-Gen Metal Fab, and we'll talk to you next time.
The Next-Gen Metal Fab Podcast is a production of the Fabricators and Manufacturers Association and part of the FMA Podcast Network. The show is hosted by Tim Heston and Caleb Chamberlain. Email them at podcast@fmamfg.org. The podcast is produced and edited by Gareth Slaker and Dana Weicker. Additional production support by Dan Davis, Andy Flando, Mike Owens, Billy Culpa, Elizabeth Gavin, and me, Sarah Spring. Thank you for listening.